Hey guys, good afternoon again. Okay, so how I want to show this demo is keeping in the audience here. I believe some of you may be trying to do some POCs. Some of you may not have already tried any LLMs or anything. Okay, so different use cases may be there. I wanted to split it into two. One is a very simple implementation using RAG where you can straight away go to your customer with the POC, with the prototype, showing, hey, this can be done for our product using AI, and this is the solution we are giving. And from this, we can develop, advanced concepts and move further. So let's say you have an idea in mind to use RAG, but you don't want to implement too much, or you don't want to spend too much time on building a RAG solution by yourself. You just want to take, go by simple plug and play, features. I will tell you how to do that. We will use OpenAI for that. Not only OpenAI, Gemini also provides similar capabilities, I believe, but we will stick to OpenAI. Next is, let's say I'm okay doing a RAG solution by myself. Not like, again, it's going to a third party RAG provider, but still you will have to do the pre-processing of getting your documents chunked and embedded, and storing it in the vector, access the database, and retrieve the information from that. So the difference between the first and the second is, first one, you just provide the documents to OpenAI, and you don't say anything else. OpenAI takes care of doing the entire chunking process, embedding that, storing it in vector database. When you ask a question, retrieve the relevant information, and provide you the answer. So this is one method. That is the easiest, simplest or fastest way to go for a prototype. Second option is building a rack solution using Pine. In this case, we will use Pinecone, which is a third-party vector database provider. Okay, so we'll start with that. For this, if you have not used OpenAI, I think it's time to go there and create an account and see what you can do there. Okay, so if you go to platform.openai.com, you can just register with your email and go in. Okay, so in this case, what I'm going to show is how to use OpenAI's vector database by itself, and get your RAG done. Okay, so let's a brief overview on this platform. You can go to this dashboard and you can try a lot of things here. Okay, if you just do a create, you can play. It's like a playground where you can play with a lot of things. Okay, so first thing you may want to do is to get an API key. So you have to go here, and you have to create a new API, new secret key, which is like an API key that you will get, and using that in your local environment, using Python or JavaScript or whatever you want to use, you can use that API key. So there's a to use OpenAI, you first have to get the API key set up for you. Okay, so let's assume you have got that. Okay, let's first check. I have actually built a small application locally so that I can demonstrate you everything. Stop me if you want to, if you want me to explain anything. Okay, okay. So first we will make a simple OpenAI call where we don't we have
I
not
think
given
Prem,
any
you are
doc.
in mute. Oh,
I'm not in mute, am I?
No, we could hear you.
Okay, yeah, thanks. Okay, so what we are going to do is we will, take our EC group policy documents, some of the policy documents, and try to create a rack solution on top of that. and see how it works and how to implement that basically. So we will first start with going to OpenAI. Okay, there are multiple models, so I've just chosen GPT 4.1 Nano and Mini to work with. We will just stick with Nano, the cheapest one. And for any LLM, it is like you will give a system prompt and a user prompt to get an answer. And there are some parameters like temperature and maximum tokens to use that you can set. I'll leave them to default. What we need to know is we will, this is a system prompt. Let's say I'm saying LLM that you are the HR head of EC Group International. Okay. And explain me about my leave policy. This is what I'm going to ask GPT 4.1 Nano. No documents is available. Remember that I have not given any document. Kavita has given me document, but I have not given it to this LLM, right? So I'm going to see what's happened. So I'm, sending this request, and I've got a response. Okay. So before that, let me tell you what is the code behind that. So to call, a model, this is a simple API. In Python SDK, you can, it's different for different languages. You can check that in the API documentation of, sorry, not here. Here, if you go to the API reference, you can find all the different ways you can call all different APIs available. So that will give you a good understanding. So I have used the chat completion API to create. So I'm saying the model to use GPT 4.0 Nano messages. The messages are nothing but system prompt and the user prompt that I'm giving, the temperature that I have selected, the maximum tokens I'm saying it can use. So this is what I have asked, and I have got a response. Certainly, while I don't have access to specific policy, I can provide you with general overview of typical leave policy that many organizations follow. So it gives you some information which generally others follow. It is not giving anything specific to EC group. Okay. So which is like, I don't, this is not going to work for me. You cannot use this as a chatbot for EC group if somebody wants to know about EC group, right? And so how much tokens it has consumed, let's say. So prompt token is 26, which is the question that I asked with the system prompt. Along with the system prompt and the user message, it comes to 26 tokens. And completion tokens is the response that is given, and it is 430 tokens, and overall it is 456. So this is the entire thing, right? So you all now understand that it is not the right answer, and to make it better, if we are able to give some information along with the system prompt and user message saying, hey, these are my policy documents. Okay, this is my policy document that explains about leave. So go give your answer accordingly. Okay, so that is where vector database comes in. Now we have plenty of documents, hundreds of documents we have. Let's assume we can use some 20 of that. Kavita has given me some 20, so I will take that, and let's say we put everything into a vector database. Okay, so now coming to the quickest solution, which is using OpenAI's vector database. I'll tell you what to do. Okay, now let's go to OpenAI. So I'm in OpenAI dashboard again. So there is something called storage here. I'm going here. In storage, you see the vector stores, right? So this is nothing but a vector database that you can create. Okay, so I have created one database and I have added all the documents that Kavita has given me. These are the different PDF documents. Okay, and if you see, it has an ID. So the cost, it says that 32 MB hours so far this month is used, which is like one 10 cents per GB per day. So if you have 1 GB of data, you will spend 1 cent every day, which is like 30 cents a month for 1 GB of data if you are using a vector store. I will tell you how to create a new vector store. You can go click here, create a new vector store, just give a title, and you can just upload your documents here in the add files. So if you just do an add file, drag and drop your files, that's it. That vector store is ready. So we will not create a new one. I have already created one. As I said, I've already created one. So that is this, and I have loaded some files. So this is what we will use. What's this? Okay, it has created one already. I will get rid of that. Okay, this is the old one that I created, which has files. This is a new one, which is you know I will delete this. Delete vector store. Yeah. You can create a number of vector stores. Let's say you want to have a different vector store for different customers. Just go ahead and create different ones so that you can use specific vector stores for your specific clients. Or within a client, you want to have different departments, documents stored in different things. Just go ahead and do that. But one thing is, it doesn't give you any additional capabilities of knowing what it is going to do. So the moment that you upload a document here, what it is going to do is it is going to do the process of chunking the data, providing an overlap, and storing and creating it as an vector embedding and storing it in the database. So when you ask a question, it is going to apply semantic search behind the scenes and retrieve chunks from that. And how many chunks it is going to retrieve, that you don't have control over it. Okay, so it is going to retrieve something relevant and it is going to give you an answer. So this is a simpler solution because you are not going to do anything else apart from just making a call to OpenAI like this. So this is what exactly you are going to do. You just throw the documents there. Those documents are available, and simply adding the documents here and doing the same, calling the same thing will not work. We will have to say use that vector store. Now we have the vector store and there is an ID. We have to tell OpenAI to use the vector store here in this thing. Okay, so let's see how that works. So this is now this is a page where same system prompt, same question. This time I'm saying the vector store ID. So this is my vector store ID. Here is where I have loaded all my documents. So find out relevant information from that, and you give me that, give me a response. Okay, same model I'm using. Everything else remains the same. So let's do it now. Okay, so the code here, if you see, the this tools is additional thing that we have here. Okay, the tools talks about file search. So the in OpenAI there are multiple different tools, like if you see tools, there are code interpreter is a tool, file search is a tool, and we are mentioning vector store IDs. So you can even add, check across multiple stores that you have created, not necessarily one store. In this particular case, we are just giving one, but if you have multiple stores and you want to search across multiple stores, you can still do that. It's an array. Okay, everything else remains the same. Now let's see the response. So now we get this response, which is like, okay, your leave policy DC group internal comprehensive and covers various type of leave entitlements. During the probation period, employees are entitled to 1 day of leave per month, provided they work for. So this is all coming from the documents that we have loaded. Okay. So do you see the difference here now? How the information that you are getting is accurate based on the documents that you have stored, and it's completely different from. It's not going to hallucinate. It has enough information to provide you. Any questions? So what you have done here is nothing. Same query that you have, same call that you made with one additional thing saying vector store. You went to OpenAI, stored your document, created a vector store there, just dropped your documents there. That's it. You did not do anything else. You don't know what is happening behind the scenes. You have not implemented RAG solution on your own, but just using, you're calling OpenAI with just additional parameter saying this is the store ID where to look for the documents, and you have already achieved what a RAG solution will give you. Okay, any questions? One thing to note here. Okay, now let's see. In an earlier call, we saw input tokens was around for the same, system prompt and user message. 26 was the token because it just have, a bunch of 11, 12 words. But now you see the input tokens is 10,000. I mean 10,257. So where did it come from? So it all came from your documents that you have stored. You have stored so many documents. Okay, you might have stored thousands of documents here, but it is going to pick uh, relevant information from this, and that's going to be around 30 40 chunks mostly. Okay, so we don't know how much it has taken, but it has taken some information that is relevant from your entire vector database and used it along with your input, system prompt, user message, and relevant context. That all put together becomes your input token, which is 10,257. Output token is only this, what you have got as an output response. The total consumption is this. So you will be charged for this, and not only for the question that you have asked and the system prompt that you have given. So it charges are two things here. One, the tokens that it is using to retrieve the information, and for the storage, as we have seen, 0.01 dollars per GB per day per vector database, I believe. Okay. So yes, any questions? Or anybody wants to try another question which and see whether we are getting relevant information?
Can we
So,
ask the source for it?
Let's try that. I just added, can you also provide the source of information? And let's see. Mm, The source of information is the company's leave policy document dated December 1, 2009, with revisions over time. It just said this is, it has referred to this document. It is not going to give you the entire document link or anything or the page number where it has got from, because this is one of the limitation of using this way, because it is not going to you don't have any way to add any metadata or anything. This is page 1, page 2, this is the document title, and things like that. Okay, it is just going to take everything, chunk it, store it, and give it. So you don't have the flexibility of uh, filtering within a vector database by specifying, okay, just look between page numbers 1 to 10 in all the documents. So that is a kind of a filter that we can specify, which is not possible here. But if we are implementing a RAG solution by ourselves, we will be able to do that. And in our RAG solution, in our own RAG solution, we will probably be able to specify exactly which source, which page number this information is coming from where it is being sourced. Okay, because we will be retrieving the information, we know what information is retrieved, what chunks are retrieved, what we are sending to OpenAI. We will know that in this particular case where we have given everything to outsourced everything to OpenAI, we will not have that clarity. Okay.
Yeah. Okay. Thank you.
yes, by giving the correct details, we will be reducing the tokens, one thing, right? So here what we did is we are asking the same question again, but we have in the response sections that cached information is not still it is zero, right?
You are asking about caching.
Cache tokens.
Caching comes into play only if the tokens that you are sending matches exactly as it is for a specific number of tokens, at least 1024 tokens. From token number 1 to 1024 should match exactly. Then only it will be using caching. Otherwise, it will not be using caching. So in this case, upfront it is different because we have added some additional information in the user message, so it is not going to take from caching. It's a new thing.
Okay.
But the question remains the same, right? We're adding
It doesn't matter whether it is a question or not. Whatever
so
information you are sending is what is
based in tokens
yeah.
only. Yeah.
Yes.
So if the in our RAG and vector database, if some information is not available, means will it expand to other public databases for search?
It depends. You can specify that whether it can use its own knowledge or not. Usually it will try to use its own knowledge, but you should restrict it to say that you should not use your own knowledge. You should answer only based on the context I'm providing, because that is what you want. You don't want it to use its general knowledge, which is outside your proprietary information, right?
Mm.
It depends on the use case. If you want to
Okay.
do a web search and do it, then there is a tool, inbuilt tool that you can use. Along with the tool, here you will say web search as a tool. Okay, so that's a separate topic, but that's part of the tools.
Okay.
Good.
Thank
How about
Great.
the files that we had stored to implement this? Let's say for an enterprise related document that we are uploading that is considered as secured, will it, in case any hack or something, or the LLM does provides the document source to the open public, will it be can that be can that type of action can happen or not? So
Whatever you are uploading is only accessible to you, not to public. Okay, the vector store that you are creating is only accessible through your API key that you have. Nobody else. It is not going to be available to the general public and all. Nobody, even any other customer, will not be able to use that. And OpenAI, it depends on the provider that you go. But OpenAI has said it will not use anything for its training. It is there in their terms, in their privacy documents.
okay, thank you.
Yeah, good questions. Thank you. So let's now we understood the easiest implementation. Let's go to understand how we can actually do this on our own, and for that we have to follow that steps of chunking, indexing, and storing. Right. So let's see one by one. So first, let's understand what is a embedding. Okay, how can we create a vector from a text? So this is a text that we have. This is a text. So in this text or the document that you have, that is going to be vectorized, right? So that needs to be vectorized. How we can do that? Let's see that. Okay. So first we will talk about embedding. Okay. So for embedding, we need to use something called an embedding model. Okay. So there are different embedding models available. So OpenAI also provides embedding models. So there are three different embedding models available. This text embedding ADA 002 was the oldest one. It is not in use anymore. Text embedding, three small and three large. So what is small and large? If you look at the documentation, you will understand the number of parameters it is going to map every text. Okay, we saw that vector embedding is nothing but you will have a text converted to uh, numbers uh, based on the meaningness between different parameters, meaningfulness, or how close they are for different parameters. So they take 536 parameters for small, and for large it is 3072 parameters. So they map your text against all these different parameters, and put, give a number of proximity, how close they are, to a particular parameter. So once you do that for every document, you will be able to match with a question that is going. Okay, that also will be converted. Your question also will be converted to a vector embedding against all these parameters, and you will have one vector having that, one vector of your question, and have thousands of vectors of the documents. So which vectors are closer to each other when you search your one vector against these thousand vectors? Obviously, meaning, whatever is closely matching with the meaning, you will get that. So let's see that in action. Okay, so let's say we will use the small model. Okay, and this is the sample text we are going to embed. It can be, whatever be the text that you are giving here, even if the content can be full of full book information, or you know uh, a page's information, doesn't matter. Whatever you are going to get as an output is going to be like this. Okay, this embedding dimension is 1536, right? So 1536, and you see the vector embedding. This is how it is going to be. This text is actually converted to a huge number like this. It keeps on going and going and going. See, this is one of this sentence is going to be like that. Even, if it is even a single word, let's say apple, it's going to be same, so many numbers. Okay, so this is what is a vector embedding, and this number is what is going to be searched in a database as one record. So you will, every page, that every chunk that you're creating will be converted into this and stored in a database, and your question will also be converted like this and compare. Okay, so and if you use this text embedding 3 large, then it is going to be double the size. So what is the difference? Small, I mean, between small and large, more number of parameters means more accurate. You are comparing with double the size of parameters. Parameters nothing but apple can be one parameter, game can be one parameter. Let's say, a bundle of words that you take, a bag of words representing different things in the world, and you are comparing your text against all these and seeing how matching they are. Let's say your word is cat, and apple is one of the parameter. Cat and apple, how far they are? Okay, mango and apple, how far they are? Mango and apple may be closer to each other because both are fruits. Cat and apple may not be. So cat will be farther from apple. Um, uh, you can imagine that way, right? So that's exactly is happening in the embedding here. So this is what does it. This is going to be around 1 MB of data, at least, right? Because we have so many numbers involved. So every record like this is going to be 1 MB or close to that, and it has to be stored in a database. And that is why we have a specialized database called vector database. These numbers you cannot search by anything, right? You cannot give a matching SQL query and all. So you need to have a semantic matching mechanism, which is like the distance of these numbers. All these parameters are taken into consideration, and compare each parameter and see, finally, between all these parameters, what is the final closeness between a particular vector and a question vector that you have asked. So pick the immediate, or nearest ones, nearest meaningful ones. Okay, any question on what is an embedding here? This is just embedding, we have not even stored it yet. We'll go there. Okay.
Yeah, all the informations are converted into some values, right? Vector and values.
Yeah.
How it is referred to the text, actually, given text.
Yeah, this apple is one single word. Okay, and the single word is converted to this number. So what is this number? This one number represents what is the meaning, distance between apple and one of the parameter of this 100 and 1000, 536 parameter. If this parameter was a cat, okay, and this is the number, between apple and cat. If this parameter is mango, right, the number will be different. So let's say this is cat, this is mango, this is aeroplane, this is cricket, this is ball, this is bat. So you are comparing this apple with so many parameters. Those parameters are considered as vocabulary in English, but it's not the right meaning. But to make it simple, assume that you have so many 1536 different words from your dictionary, and you're comparing apple against it in its meaning. Okay, then you get this number. This will be different for each of the every text that you are giving, right? So you put this in a vector space. So this is the dimension of the vector space, and you will get a point. Next vector you will get a point, and you see how far they are, and that is the semantic search.
So these values will be the difference between these two
Distance.
data. Yeah.
Yes, distance. Yeah.
Okay.
So, as per my understanding, uh, from Apple, there is a value considered as 1, and for orange, we have a value as 10 in the sense this vector embeddings will be 10 minus 1, I will get a reference number. 9
Yes.
or something like that. So if apple compared with fruit as a word, it is close resemblance in the sense 3 I have number, so 3 minus 1 it will be 2. So this vector embeddings will have a value 9 comma 2. Uh, Am I correct?
Correct.
Okay,
Correct.
thank you.
Okay, good. So hope it's we are able to visualize and understand what an embedding is. Okay, so let me do one more thing. I will show you visual. Let's say you're able to see this page, right?
Yeah.
So you can see this is how it is in a space like this. It's a very small. This is not 1050, 1536. Let's say this is two or three dimensional, two dimensional only. In this case, graph, money, stock, these are all closely related. They are in this side. Apple, banana, burger, pizza, these are all something that you can eat. They are the side. Okay. And mountain, these are the side. And if you give a new word, and you can see how close it is to uh, where it is actually going. Let's try a word. It may not be exactly getting you the right response, but we can try. Okay. How can I'm just giving a question. Okay, how can I earn money? This is my question. Let's see. And it says it goes here. Okay, because there are so many how can I earn, so many things are there, it comes here. But on an actual space, if you see, it may go somewhere near here, because it's all it's talking about money. Okay, so that's how you these are all the documents that are available. Okay, all these are the documents that you have uploaded and store already available in your vector database. And a question that you are asking will be matched against the documents, and it may go anywhere, and you will pick the closest ones to you. That is the concept of semantic search. Got it? Yes. Okay, let's move on. So now we understand what is embedding. We have to, if you are implementing a rack solution, so what should you do? You should first chunk your documents, create embeddings, right? So it's a small demo of that. Let's say we have a document, and we will load that. Before that, let me also tell you about Pinecone, which is the vector database that we will be using. Uh, so I will go there and explain that. So a document, we will have to now create embedding, create chunks, and then create embeddings and store it in the vector database. So that vector database is Pinecone. We'll go there. Okay. Pinecone, if you see, um, this is what Pinecone. It's a third party. It's a database provider, you can call. It provides a way where you can create databases and store vectors. Okay, they call it indexes. Database, they call it indexes. Nothing but a vector database. So you can create an index, which means that you can create a database. I have already created a database called demo rag. So I will show you how to create a database. So they provide two ways, server and serverless. Serverless is the cheapest one. So we can just go ahead and create for your use cases when you're doing hackathons and all. Just go ahead, log in, and it's free. I mean, you don't even have to pay for it initially. I mean, for you have some free usage. So you can create a database. Let's say I will say demo two. Okay, demo two, and it is going to create a server and it's going to store it somewhere. So and uh, there are different configurations available. Since we will be using the embedding of text embedding 3 small, I will choose this configuration. So if you see this configuration, it comes with vector type is dense, forget about it, max inputs and dimension. So we go with 1536 dimension, we will select that. And metric, how to match. So it is called cosine similarity. There are multiple other ways, but if you choose this one, it's going to be cosine similarity. Don't worry about that. I don't need to know that. Uh, and it's serverless, and they will be storing that in AWS. Basically, it's going to be a pod that will be sitting in AWS. And the regions, you can choose them or you can just leave it as it is, and you can create an index. If you just create an index, you will get something like what I already have. I already have created one database, and you can see, and you can just call it by this. You will get a link like this, and this is what you will use in your API to call Pinecone to interact with this database. You will use this host, and you can actually create an API key here. So you definitely need an API key to connect, right? So you will have to have an API key generated from here, and that API key is what you will use to connect to Pinecone. The earlier one was OpenAI. This is Pinecone, just for vector databases. Okay. So here, let me go inside, and you will, a database. We have created a database now, and within the database, you will have tables, right? So let's say you have you have created one database or one index for your customer, and within that you want to have different tables. Okay, one table will have specific information, another table comparative SQL database, and consider like you will have different tables allocated. Okay, so that is called namespace here. A namespace is nothing but a separate table. Okay, so for documents that I'm going to upload, so let's say I'm creating a namespace called simple test. Okay, so I can just I don't have to even create anything here. While uploading the document, I can say put it inside a namespace called sample test. It will put it there. It is like a partition within the table. You have a partition. Any record that goes with a namespace sample test is only within that namespace. And you can, if you delete the namespace, entire records is gone. Rest of the things will still be there. So that is the idea. Okay, so just understand what is an index, what is a namespace, and what goes inside that. We will see that. Okay, any questions on Pinecone?
What will be stored in the namespace? Actually, namespace is something like we are creating a table or something more
It's
than
a
that.
table. It's a
Okay.
table. You are going to store records inside that. So what record you are going to store, I will tell you. I will show
Okay.
you.
Okay.
Yeah. Okay. So now we have documents. We need the document to be stored in the vector database, right? So let's see step by step what we can do. Okay. Let's take one document. Let's say I will take this document. Okay. These are all the policy documents. I will take this one. Just give me 1 minute. Sorry. Let's say Okay, sample disk. So I'll change the namespace so that you can see that it is created new. Okay. So I will drag and drop a file. This is a page where I can upload a PDF. This is created in Streamlit. You can do it in any way. I'll show you the code. Where to upload to how to upload to Pinecone. But this is the initial process. Initial process. I have dragged and dropped the file. So this is a PDF document, and behind the scenes I have used a package called PyMu PDF to extract the text from the PDF. So I extracted and I see that there is one page and it has so much characters, and this is the text information. Okay. So this is my first step, extracting text from a particular document. So this is one page. Let's see another document that has multiple pages. Let's go to this Posh. So I drop it here. So it has around sorry how many pages? 3 pages I have. 3 pages. Okay. Okay. Now, this 3 pages, if you see, this is the text extracted out of those 3 pages. Okay, page 1, page 2, page 3. Now, I can store this entire page as it is as one chunk, or usually what people will do is they will chunk it further so that smaller chunks is better. Okay. So this is 2465 characters. So we can probably split by 1000 characters each. That is called chunking process. If I chunk this page into 1000 characters, this page one will get converted to 3 chunks, 1000, and 465. Page two similarly, page three same way. So that is step number 3. You have to split the document. This is not AI. This is all programming. Extract text and create chunks. Okay, so this 3 pages got converted to 10 chunks. And what this chunk is, if you see, this is coming from the chunk 1, page 1, 1000 characters. Chunk 2, page 1, 1000 characters. Chunk 3, page 1, 865 characters. So you can ask me why 865? It was only 465. How come 865 coming here? Okay, so I have actually given a overlap. So a concept of overlap is important when you are actually chunking, so that you can, by giving an overlap means take some information from this, the last few information from here, and add it to page, the next chunk. You see here, this until this information it's coming from here, chunk 1. Okay, and similarly from here also it will go to here. So that way you create a link between these two three documents, because they contain same information, they will have some similarity, so that when your vector search is happening, both documents will, both chunks will be nearer, and you will get both. Otherwise you may just get random information which is not which may not help you. So that's one technique. This is one of the techniques where you can have overlaps to get relevant documents. So this is chunk 1, chunk 2, chunk 3, and there are 10 chunks like that. Okay, so these chunks now, again, until this point it is all text. Chunk 1 is a text, chunk 2 is a text, and so on. Now we need to convert all these chunks into embeddings. So the previous step we have seen. So take entire this thing and call the embedding model, convert that to vector, which is the array of numbers, and then go store into the database. Okay. So let's say, so this available chunks are available now. So I will upload that to Pinecone. I will show you the code of Pinecone. Okay. So you can see this is the embedding. First, I need to create embedding, right? Because I need to convert that to a vector. The same code that we have seen earlier on embedding. So using this text embedding 3 small, for that input, we have created that embedding. And this embedding will now be stored to Pinecone. So Pinecone, as we said, if we are in, if we have the Pinecone package available, I mean the SDK available, you can call it, you will initialize it, and it has an index, and inside that index you are going to upload vectors. So these vectors are going to have some information, like you will create a chunk ID, because everything you need to have an ID, right? This embedding is all the values goes with the embedding. What is it? This is the the array of numbers that you have generated. This is what is the key thing that will consume all the data in the database. So this is what is the main thing. Okay, along with that we will add some metadata that will identify, or that this is only numbers, right? You cannot extract any text out of it. How will you get this same text out of this vector embedding? You cannot convert it back. Okay, so what we do, we will add that text, whatever it is, as a metadata. So this big number, big array is going to have a metadata that will have this text also. And we can add any number of metadata. I am adding page number also. I'm adding the character counter, the file name of that file that I'm uploading. All these are metadata, so that I can use any of these things to filter data. So I have a control over what vectors I want to restrict my search into. If I want to search only within specific files, I can specify, search only with these files. If I want to specify within certain page numbers, I can specify that. So that's the advantage you have over maintaining your own databases. uh, so did you follow, or are you okay? This is the code. I will show how the data is sitting there. And namespace, you can see the namespace we have specified. In this case I have specified a new namespace. So let us go to Pinecone and see whether the data has come. Okay, so this is the thing. I'm going here. Okay, okay, I did not actually do a refresh, so it went to the same sample tester. Anyway, that's fine. I can show you, I can browse and show you how that data is. So this is a namespace, and let's do a filter. So the filter by document, let's say we will do the document. The document name is what this. I'll take this file name, right? Is this the right one? File underscore name, yeah. So metadata is file name equal to values PDF. Yes. And this we need to do a random filter. Okay. You see, you have 10 results and everything is coming from this. This is what is stored. This is the text, okay, of each of the chunk. You won't see this numbers here. That number is actually stored in the database. It is not going to be shown here. But when you are matching text against that, you are going to match against the vector only, and this is what is retrieved. You will not retrieve the 1 MB of data, which is the actual vector. You will retrieve only the metadata, so it is very small. So it will be faster. Okay. So each chunk is now uh, stored like this. Okay. So what I basically did is I generated some random vector, random text you can call, and matched against the vector database with the filter saying only restrict your search for this file name. Okay, and get me the top 10. Since it's a random vector, it went against that and took all the 10 ones. And you can see the score here. The score, the more the score is, closest it is. Okay, so that's how you pick the closest matching vector. I will show you that in a minute, but this is how the data is stored. Whatever you have abstracted, that has come here, that is available here. I've added some around 15 documents, whatever we have seen there, and that's why you see 62 records. So 62 chunks are already available in this namespace. Okay, so now it is ready for us to search. a given text. We have taken a document, we have splitted the document. Where is it? So we've taken a document, we have splitted the document into pages, and from the pages we have split it into chunks with overlapping, and with the chunks, those chunks are uploaded to Pinecone using this code. I mean, they were actually converted to embedding and then uploaded to Pinecone, and this is now available in Pinecone for us to search for our RAG solution. Understood? Can we move on to the next one?
So in vector DB, we will not only store the difference between the A element and B element, we will also store the A and B value in corresponding the same namespace.
Yes, yes, yes.
Oh, okay.
Vector, what we are storing, see, we have a defined set of 1536 parameters. Okay, that is constant. That parameters are constant. Each of these chunks are taken, and you have seen the you have generated that embedding, which is like the distance between each parameter for this text is generated, okay, and stored as a vector. Same thing happened for this text, same thing happened for this text. Okay, so all these are 9, 10 different vectors sitting there. Okay, now you are going to take another document or another text, do the embedding on the same 1536 parameters, and see out of this 10 which one is closer to your question that you are asking. Okay,
Uh,
that's
it is not about storing a particular word like comply as a word. Is it not storing like that, or that's my doubt actually.
no
Uh,
word, no word is stored. It's only
uh,
the entire text is one word you can consider.
okay.
Okay, it's one, you cannot call it word, but it's one data or object. This object is compared
Mm,
against this 1536 generated distances with that. Okay, that is one vector. This is
okay.
another object that has, same, concept, and it's a vector. It's sitting in the vector space of this 1536 dimension.
Yeah,
Okay, yeah. Any other questions?
thank you.
Let's go to retrieval process. So now that we have that information in Pinecone database, so we will, actually query with some uh, text and see, and we can get any number of, matching. So it's going to give you matching elements. It is not going to tell you any answer. It is not going to give you an answer for your question, but it is going to say, okay, you asked this question or you gave me this text. I see, these are the 10 top matching documents or vectors that may be, closer to the question that you asked. So it's now up to you to get your answer from that. So let's ask a question. I will ask, what is my leave policy? Same question. Okay, so let's see what is coming. So I'm not applying any meta filter. First, let's go with no meta filter. We will get top 10. If you want top 5, we can say top 5. If you want top 20, we can say top 20. It all depends on the context window we have, right? We have a lot of context window, you can get more results and send more data. If you want to restrict to only few, you just restrict to few. Let's keep it 10. I'm searching. So now what I have done is, so this question is now taken, and that is also embedded the same way. I embedded the other documents. Now I have another vector. This vector is not inside the database. This is the vector I generated for this particular question. So now I need to compare this vector that is embedding against Pinecone. That is where this query comes in. Okay. This is the Pinecone query I'm doing. So this is the index I need to use. I'm saying query this index with this embedding that I have generated, and top K is 10, include metadata because that's what I want, and namespaces, the given namespace. So now it is going to go up against the database. We'll take this one vector, compare it against all the vectors that are available, take the topmost 10 closest vectors matching this one vector. Okay, so that's what has come as a result here. So if you see result 1, 2, 3, so these are all high margin score 63, which is like you can call it 63% matching. It is coming from the leave document. Okay, and this chunk is 62% matching. This is coming from another document, leave application procedure. This again leave policy, but a different page, so different chunk of that page. Um, leave application policy, leave encashment. So you have plenty of documents, but all these informations are closer the top 10. If you give top 20, you will get another 10, but your scores will go keep on going down. Okay, it's up to you to decide which to take. So I have these 10, and this is coming from maternity leave. So you have so many other documents. You can see the number of documents is there is compensatory off. You have employer referral, open door policy, harassment. These are all not considered because they are not closely related to. They are not actually in the top 10 of the space for the question that you asked, because you asked about leave policy. Information within harassment is not even close to leave policy compared to other documents. So you got these 10 top matching documents. Okay, so if you have 1,000 documents, million documents, doesn't matter, you get the top 10 matching. Okay, so that's the key idea here. Okay, now you got this 10 documents, and now it's time to take all these 10 documents, give it to OpenAI as a context in the context window to get you the answer. So until this point, there is no AI. It is all about mathematics. You have splitted the document using logic. You have stored that using a vector embedding. Vector embedding is nothing but a mathematics. You are converting this to seeing the distance and doing it. There's no AI involved here. It's stored in a database. You have retrieved it using a cosine similarity matching, which is semantic search. You have the text with you. Okay, until this point, no AI. AI comes only in the next step, which is you have a system data, system prompt, you have the user prompt, and you have the context now. Let's do that now. So now assume that I have same question, model and number of chunks to retrieve. Let's say 10. I mean, this temperature and other things are there. And now this question is going to go against the Pinecone database. So the same thing that I have seen shown you there, it is going to fetch same documents and it is going to send to OpenAI. Now let's generate. So first step is again embedding your question using the embedding model. Embedding is you got a vector. Second step is retrieving from Pinecone, same query that you have already seen, passing that vector embedding of this query, you got top 10 records. Third step is all about, see, this is where you will be passing to OpenAI. So I'm saying the system prompt is this, user prompt is this, and this is what is sent in the user prompt. I'm saying here is the context. Retrieved chunk 1, I will put the chunk 1 here. Retrieved chunk 2, I'll put the chunk 2 here. So I have retrieved 10 chunks, so all the 10 chunks will be there. And question, this is my user question. I'm saying answer the question based on the context provided above. This is what is going to OpenAI as a user message here. Okay. So not only this, you ask this, but I am augmenting that with all this information and sending it to OpenAI. And I got the response. What did I ask as a question? What is the main topic of talking? Okay, I'll ask what is my leave policy? Same thing is happening. It's retrieving and then it will execute the code. Okay, so this is the answer I got. So answer I got is this, and this is based on the retrieved chunks. As you see, this 10 chunks. that you have sent. So we have sent information from this file, from this file. The information will come from various files, and it has finally, used that all the information provided you comprehensive answer. This is what is all RAG about. And token usage, again, if you see, so you know how your token consumption is. Earlier, for the same thing, in when we did OpenAI vector database, we have seen that it consumed 1,000 tokens, because we did not have no, not 1,000, 10,000 tokens. We did not have control over how many chunks it can take, how to chunk it, no, nothing. Now we have controlled it by saying only take the top 10. So the top 10 included only what? Less than 2,000 tokens. So you have control over your cost if you are using your own implementation. You have control over what to take, what to send. If you want to do advanced RAG before sending to OpenAI by further enriching this data or filtering this data, you can still do that. That is what is advanced RAG is going. Okay, so this is all about RAG and its implementation. So immediate step, if you are doing any hackathon or anything, so first go for OpenAI, understand the situation, understand how it works, and then gradually go for implementing your own solution like Pinecone. There is few more other solutions as well. Quadrant is one. So there are many. You can check. That's all about it. I believe I covered whatever I wanted to. Any questions? Being silent makes me feel whether you understood any,
Yeah, it is. It's a great section. And one last question on this. The last part of chunk that you provided to the OpenAI as a context, and it gave a word that it formed out. Is it just appended the text, appended the chunk, and give us an output, or it from that chunk of multiple chunk, it the OpenAI started filtering out something and generated a text? How the final output came out? That's
that is it is going to use that information and provide you the answer in the way you want. Okay, so if I put my system prompt saying you should structure your response like this, I want your response to be in this format, in this style. Okay, all these things you can specify and it will comply. So it is nothing but you are, if you are asking a question to open, chat gpt, you are getting some response. Same thing is happening here. Only difference is you are giving additional information to it. In case of chat gpt, it is going to take the information that it already knows. That's the difference. It is not going to take exactly and use the same words here. If you want it to use the same words, you can specify that, it will do.
okay. So currently, what it did in the background, the OpenAI again chunked on the on background of is
No,
is
not really chunking and all. See, chunking is just splitting the data. Okay,
okay.
split file is
So
called chunk.
my doubt is, what did the OpenAI did here?
OpenAI had the data now. It had
Okay,
your question had, instead of 10 words, your question now had 1,000 words
okay.
along with your question. So these 1,000 words contain information that is useful to answer your question, that it should use to answer your question. So it read that, it understood what it is, it has formulated an answer like a human and gave it to you.
Okay. So here normally OpenAI, I thought the behind the scene they are doing the chunking whenever we question or something. I thought that. So it's not that. That's your to say. Okay.
No, it is because it's already done and available. So like how we have got from Pinecone, Everything is available, everything is done during its training process itself. Okay, that is how it can generate the
But
words.
what we had given as a context, that would be new to OpenAI, right?
Correct.
So
So
then again, it should do a chunking process in background or not?
no,
No.
no.
Okay. Thank you.
Any other questions?
And here, while using the chunking, we have the chunk text or the metadata, right? So OpenAI doesn't use these informations. Only that vector informations are used in the open search
That we don't give vector to OpenAI. We only use the text. We
text
use
to.
vector only to get the text from the database. After that, vector is not involved.
Okay.
Vector is just like a record in an object that contains your text. Okay, so you go into the C and you get some boxes, and inside the boxes you have a letter. uh, okay, and you collect only the letter and then go to OpenAI with only the letters. This big box, which is a vector,
Okay.
is not sent to OpenAI. The vector is nothing but just number. You don't send that.
Okay. So whatever in the vector information should be present in the chunk text also, that
Yes,
text
you
contents.
should put your chunk information and as metadata. Another way is to you can maintain your text in your own database with a key saying that this is my key, and you can use that key as chunk ID, and you get the chunk IDs, go to your own database, retrieve the text from your database for the matching chunk ID, and give it to OpenAI. End of the day, OpenAI wants data. That's it.
Okay.
How you manage that, up to you. Okay, there are no further questions, Kavita. I am done. Thanks, everyone.